All right, so just to recap where we were and where we are going. So we've talked about methods, we've talked about arguments, we've talked about parameters. We've started to pass arguments into these methods, but we want to also talk about how these methods can return particular values. We create these methods, and other programming languages, they're also called functions. We create these methods in order to do a very specific task, okay? If a method is doing too much, then typically that means that you need to create multiple methods in order to accomplish that, because we want to break things down and we want to make sure that things are as simple as possible, so that if we're reusing our method, that we're able to pass it in arguments that it can take and perform different calculations with. We can have a method that performs several different methods once those methods are created, but we want to be able to be very specific when creating these methods. If you have a method that's doing like 20 different things, then you should probably break it down to separate methods. So we're gonna talk about calling methods that return values. It says, if a method is a void method, okay, we've used some void methods, and it hasn't had a return type, meaning that when you run the method, the return keyword is not used. You can call a method and make it system.out.println and make it do something, but the method didn't actually return anything. So we've had it as void. Okay, so if the type is void, okay, we've seen most of these types of methods so far, it doesn't actually return anything. It says, but some methods return a value back that the program can use. We want to use our methods in order to also perform some sort of calculation and then return a value back. So let's talk about this. Okay, get methods. Okay, there are get methods, there are set methods. It says get methods return the value of instance variables. For example, if you were to use a get width or get height method, you could get the turtle's height and width from the turtle class. Okay, those are methods that exist. It says in the previous lesson, we used some set methods with parameters, how we set color, we set width when we were using our the color class, as well as when we're passing the 50 argument when we're setting the width. Programmers create get and set methods for each attribute represented as an instance variable in a class to access and modify the value in that variable. Okay, so we'll talk about get methods. We'll talk about set methods as well. It says when you use a get method, you need to save what it returns in a variable, or use the value in some way, for example, by printing it out. The data type of the variable must match the data type of the return value of the method, must match it. You can find out the return type of a method in its documentation. It will be right before the method name. All right, so here's some examples of using get methods for turtle object URL. Okay, so we have some code here to look at, and if we're using the turtle class, right, we're creating a turtle object called URL, and we're placing it in the world. Okay, once we've created that, we are then creating a variable called width, and we go using the turtle object, we're able to go and receive from the turtle class a method called get width. Okay, and we're able to access that attribute and then assign it to a new variable, which means that this method automatically returns a value. Okay, it's asked, it's already behind the scenes, it's written, and it uses the return keyword in order to return a specific value. Then I have int height doing the same thing. So then we can use those attributes that are stored now as variables and we can use them in our main class, whatever class we're using this in. Okay. We also have, since we have the turtle set up, we can get the X position, get the Y position. A common error is forgetting to do something with the value that's actually returned from the method. Okay, it says try the code below that changes the turtle's width and height. How big or small can you make your turtle? Okay, so let's just run it, see where it's at. Okay, its width is 15, and then it says its width is 200. So let's take a look at this. We have set it to 200 here. We've set the height to 200. The question that it asked was, how big can you make your turtle? Okay. Let's see if it goes beyond 300. Okay, so that's 300. Let's see if I can pass it past 300. Let me say 500. And then it just becomes the full screen, right? It says your width is 500 here. Originally it was 15, and then it's set to 500. I mean, in terms of my world of what I can see, I can't see anything now because it's gotten so big. Okay. It says fix the errors in the code below so that it prints out the area of the space the turtle occupies by multiplying its width and height. Remember that you have to do something with the values that the get methods return. Okay, so errors in the code below. So it prints out the area of the space the turtle occupies by multiplying its width and height. Okay, we can't just use get height. We have to make sure that the object that we created is listed here. And we also need to have our open and close parentheses. All right. Yertle's area is, and then we also need to say area is equal to that, and we'll add area at the end there. So we create a variable, int area is assigned a value. I could just write it all in one line. Okay. And then to print it all out, let's take a look. Let's see if I did anything wrong. Okay. So we're able to do that. Okay. We have our area variable. I mixed up area and variable together. And making sure that we have our object, our dot separator, and then our method. Okay. Ending a semicolon. 252 says toString methods. Another common method that's used is toString. You're taking a data type and you are making sure that you're using a string. Okay, it says this method is called automatically to try to convert an object to a string when it is needed. In the turtle class, the toString method returns a string description of the turtle. All right, so if you were to create a turtle object called Yertle, and then it says Yertle.setName, Yertle, and it sets the name before you set it to string, and then you say Yertle.toString, and you can print out that. Looking below, it says try some of the get methods and the toString method in the program below. Note that you have to print out what the get method returns, what the get methods return in order to see what they do. Okay, so try some get methods below. So some of the get methods, just to refresh, we use get width, get height. So maybe we can print some of that out. We'll see. So maybe I can just say system dot out dot print line, and I'll say Yertle's width. Okay, and we'll say Yertle dot get width. And if you're looking up here and taking a look when we use this before, right, this is going to be stored as an integer. So let's see what happens if I were to just run this. Okay, there were errors, and it says Yertle's width. It says there's a semicolon expected after there. Right. Well, that was as you're listing Yertle.getWidth here. Okay, it's returning an int value. Okay, and we want to be able to use also this method that we just talked about, the toString method. If you were to try this and just get width, you're going to also be able to with multiple dot separators. Okay, you can use multiple dot separators with one object. So even though I'm using get width, right, I can also use toString. Okay, I can also use that dot separator as well. Okay. So it's saying, oh, I'm not using concatenation properly. Sorry.
Does that work regardless if you're like it with the instance of the integer class?
So you're asking, would it work without get width or without toString?
So if I did, you can do dot toString on it, because you're like it with the int dot, but I'll need to place integer, which is what toString is do method of. Yeah. So you have
It cannot be dereferenced.
so you need the integer class to call toString on it.
Oh, gotcha. So the mistake that I originally made was just the concatenation. I was wondering, I'm wondering why they're introducing that right there. Yeah, so I made the mistake of just not concatenating it. Okay. So make sure you add this concatenation, you're adding the two together. Okay. I can add a space there if I want to. If I'm adding another one, I can say system.out.println and say Yertle's height. And I can add Yertle.get height. All right. And run it. And now it prints out Yertle's width and Yertle's height. All right. Call toString. It wants me to use one toString. Okay. So once again, I was trying to combine all of them into one, but that obviously doesn't work.
If you pass the get width this argument to the integer constructor and call toString on it.
Yeah. So what I can do, since this is what they've been asking, or what they originally, when they first introduced toString, it says, for example, in a print statement in the turtle class, the toString method returns a string description of the turtle. If you wanted to use a similar style like they did originally, they created the turtle object, they set the name to Yertle, okay, dot set name. And then from there, we were able to say Yertle.toString. Okay, so if we wanted to create something similar, right, we could take where we're at right now. Let me take out some of these comments here, and I'll explain what we're doing here in a second. I just deleted all that, didn't I? There you go. Took out that. Take out that line. Then there. Okay, so if we're using the toString, we're saying yurtle.toString wants us to use at least one toString. Yurtle, we're setting the name to yurtle and then writing out what yurtle is toString by using the toString method. It takes it and it casts as a string. So moving forward here, now we've used it. We use it. Height width, turtle is at 150, heading 0, 0. Okay. 253, methods with arguments and return values. It says methods that take arguments and return values are like mathematical functions. They're given some input and they return a value. In algebra 2, I teach algebra 2 and we start talking about functions and students start like realizing that a lot of the math concepts they've learned in the past start making sense, and we're starting to put all this stuff together, and you start realizing the why and not just focusing on the what. And that's a cool moment to see when we start talking about functions, and you start to see input that's being put in and then an output that's applied in some real world situation. So it says, for example, a square method would take an argument x and return its square by multiplying it by itself. So arguments can be passed into the method. And then now we're going to mention, I talked about this earlier. I mentioned the return keyword, and we're going to move on with the return statement. It says, you will not write your own methods until unit 5. But notice that the return statement in a method returns the value that it indicates in the return type back to the calling method. Okay, the calling method must save or use or print that value. So, all right, attention here to 254. It says, what does the code print out? We have a class. It's called method trace. All right, we have a few different methods inside this class. This is a public method. It's going to return an int. Notice how the return type has to be listed ahead of time. If you don't list a return type, you're going to end up getting an error. Okay. Your method name, and then what parameter it will be receiving. It will be receiving an int, and we're going to refer to it as x. So when we finally use this in the main method, it's going to take an argument that the user enters. It's going to then take it into the class. It's going to locate the method. It's going to pass in that value. It's going to then multiply it by itself and then return that value. So by using that square method, it will then return a specific value. Okay. The divide method will take two numbers and divide them. So if we look just at our main method, right, let's track this. This is where the computer starts. It says public static void main. Then we create our trace object. The reason why it's called trace is just so that we're able to move through. Well, I guess the name of the class is method trace, but the reason why we call this trace object is just so we can trace and see where our method is going. Okay, so let's watch it. So we're going to use the square method. Square is passed an argument of 2. Okay, so what it's going to do is it's going to locate. I have the trace object. It's then going to go to this method trace class. It's going to find the square method that exists. Okay, it's going to check and see was an integer used? If so, multiply that integer by itself. 2 times 2 would give you 4, and then it would return that value. Okay, so it would take that value and return it automatically. So it would give me 4, and then it would add to it. So 4 plus it's going to then use back to the trace object. It's going to divide using the divide method. So it goes to the method trace class, finds the divide method. Okay. It checks and sees if the arguments you passed in were integers, and they are. So those parameters were set and they were accomplished. Then it takes 6 and 2. It replaces x with 6, y with 2, and it divides it, and you get 4. Or sorry, you have 4 up here as the first one, and then 6 divided by 2 is 3. So 4 plus 3 should give you 7. Okay, check. Long-winded, but we got to the answer. I wanted to make sure we understood that. Okay, so the main method is able to use, or any class in that matter, is able to use methods by creating objects. Once you understand the concept of classes and being able to create objects from those classes, and multiple objects in this case as well, and identifying different methods, well, the same object, but referring to the object in 2 different situations and using different methods that exist within the method trace class. Okay, 254, programming challenge. It says turtle distances. Okay, it says the turtle class has a method called getDistance xy, which will return the turtle's distance from a point. Okay, so you can put in any point and it'll tell you how far away it is from it. Just, can you find turtle's distance from point 0, 0? Okay, so we'll say Yertle dot get distance, and we want to see how far it is from 0, 0. So we're passing it 0, 0. Add another turtle and make both turtles move. Okay, then find the distance between them. You must use the get x position and get y position methods, as well as the get distance method. All right, so I guess first let's create another turtle. It's been using Yertle and Myrtle, so we'll create our new turtle and we'll call it Myrtle. Okay, and we'll create a new turtle. And we want both of these turtles to move, right? So I'll say Yertle dot forward, and I'll make it move forward 150. And then I'll say Myrtle dot, we'll make it turn right, which turns it 90 degrees. And then we'll say Myrtle, if I can spell right, Myrtle dot forward 50. Okay, and this will not accomplish what it wants. It wants me still to determine the distance between the two. Let's just run it to see where we're at. Okay, so the first one went all the way to the top of the screen. Maybe instead of 150, because that's the top, I'll just say 100. All right, so we'll run it again. Okay, so we want to find the distance between these two turtles. And when we were drawing the house, right, it would have been nice to look at the distance of how far away the line was, where each point was located. That would have been nice to do. We were just creating it, but now we're actually using these methods that exist in the turtle class. Okay, so you must use the get x position and get y position methods, as well as the get distance method. Okay, so we want to be able to, if you look at what has actually failed, we have to call at least one get x, one get y, and then the get distance. Okay, how can we go through? If I'm now turning it over to you guys, okay, if I have one turtle that started at 0, 0 and moved up 100, one turtle that turned right and moved to the right 50. Okay. The original, I guess, get distance, get distance showed me how far I was away from 0, 0. Remember, 0, 0 is the top left. Okay. Maybe if I print it out, you guys can see it. Maybe that would help. System.out.print line. You guys can see. Maybe this will help. Okay. So print it out. If you look, that's a double. 212.13203. Okay, then it performed, it went through afterwards. So how would I use the get X position and the get Y position? We're gonna have to do that with each turtle, right? So let's get X and Y position of Yertle. Let's get X and Y position of Myrtle. What's that?
Just find one of them to say get distance from the 2 points that are the other turtle.
You're saying get distance from, so you're using one XY to find. So your method that you would use is you would find the XY position of 1 and then see how far away that is from that turtle. Okay. So yeah, we could do it that way. We do have to use the get X position, get Y position, and the get distance. Okay, so we'll say get distance between 2 turtles. Okay, so Daniel, we'll use yours to start. How would you write this? So you want to get the XY position of, you want to say Yertle, right? Okay. So you tried int Yertle.
No, it was Yertle X. So I guess I wanted to-
Were you trying to get the X position? Yertle dot get X position. Like that? Is that what you did?
It's that's what I ended up doing, but I just wanted to fit inside of storing a variable and we wouldn't do it. In that situation, it would do double work. I don't know what. Well, maybe it didn't work. It worked for that one.
So you create a variable. All right, we'll go with your way. You create a variable and we'll say like X, right? Talking about something like that. And then you ran it. And I guess we'd actually have to.
The error actually might come when
So if I'm printing out what you ended up doing here, right? You found the X position. This is your error right here. Okay.
Well, you can't print. You would just print X.
Oh, yep. Sorry. I see what you mean. Okay. So printing out X here. So you print out X and then we got 150. So that worked. Then maybe we say get Y position. And I know there's more efficient ways of doing this, but I'm just walking through step by step. Okay, so we have our x, y. Okay, so we're at right now, Yertle is at 150, 50. Remember, we're starting at 0 here, so 150, 50. And that is the XY position. I didn't need to print them out. I'm just checking. Okay, so we want to identify, so what does the get distance method actually do? And it prints out the distance, how far. It says, can you find Yertle's distance from the point 0, 0, how far it is from a specific point. Okay, so we found it's XY. So maybe now instead of going with your original, I'll go with your original way of doing it, right? So we found Yertle's XY, right? So can we now go to Myrtle, right? And we can say Myrtle dot get distance. And we can say from X, Y, right? From this location, it's X, it's Y. I'll eventually go through a more efficient way as well. Some errors, recompile, okay, doubled int, I see. So it wants this as an int. So let's go ahead and can I go ahead and cast as an int there. Let's see if that works. No, it's not letting me. Still having the conversion double. Oh, because I've all right, let's run this. System.out.println. Let's see where we're at. I'll walk back through this. Okay, so let me go ahead and take out some of these print statements I was using in the beginning just to see where they were at. Take out this and get distance, print line. Okay, so let me just walk through and show you what we did. This isn't necessarily the most efficient way, but we can make it work. So first, we found out the distance of Yertle of 0, 0, right? And then, and it printed out 212.15 or 0.31132. Says, can you find this between two turtles? We made it move. Okay, I see. We made our turtle move. So I'll say move turtles. And then we found the XY position of Yertle. And then we found the distance between Myrtle and that XY position. Okay. Could I go through and in one line, could I accomplish all of this in one line of code? Yeah. All right. So, we can go through and we can take 1, 2, 3 and write out verbose code. And what I find myself doing a lot of times is I'll write it just as it comes to my head. And then I'll look back at it and say, like, how can I make this more efficient? Right? What can I do? So I wanted to write it out like this so then we can combine it. All right. So I can make this more efficient. I'll go ahead and start it here. Maybe I'll zoom in. Okay. I can, if I wanted to, I could say system.out.println. Okay. We want to find the distance between Myrtle, get distance, between those XY. Okay, so what I can do is I can say Yertle.getX position. util dot get y position. And what else do I still need to do? And I need to cast them as integers. Okay. So I'd cast it as an int there. And then cast as an int there. So long line of code, I'll zoom out. Ooh. Okay, so system.out.println. I took Myrtle and I want to find the distance between the XY positions. Now, like I said, you could accomplish it in 3 lines of code. See how I set an X instead of Y. The same down there. I'll go ahead and add some spacing here. You don't need to, but it looks good. Let me run it and see what happens. Ah. Look at that. And I was able to get the same answer both times. So you could go through and write it and do it in 3 lines of code. You could do that. That's good and great. I'm going to comment them out because you can write a more efficient. And when you first start writing programs, and that's why like I try to find the right balance. Like when I'm explaining things, I try to write it in a way that I would have written it when I first learned it. And then also in a way that is more efficient, that should be used typically in programming. That, you know, if you're able to accomplish it in 1 line of code, why would you write it in 3? Okay, so we talk about like beautiful code and clean and concise code. And if we're able to put it all in 1 line there, that's awesome. Okay, so we're able to do that. Thanks for walking through. 2.55 summary. Some methods return values. Yeah, we learned that. You know, we've blazed through that. 2.56 says AP practice. Consider the following method. And we have a method that returns a double and receives an int, which is number of people, and a double, which is slices per box. Okay. And doesn't say the code. Which of the following lines of code is located in a method in the same class as calculate pizza boxes? Will compile without an error if located in a method in the same class. Okay, so this is saying int result, calculate pizza boxes 45 9.0. The following lines of code is located in a method in the same class. Okay. All right. Anyway, I don't necessarily think that was the best wording of it, but double result equals calculate pizza boxes 45 9.0. Int result, calculate pizza boxes 45.09. Double result, and then it has an integer and a double. Okay, this doesn't list anything, right? Any sort of return type or any variable that's being received, and then calculate pizza boxes. So this is saying if located in a method in the same class, you're using, I don't like the verbiage that it used. You're using the method that was created and you're storing the result. Okay, so you know that calculate pizza boxes is going to return a double, right? So you're going to want a double as the result, correct? You're going to pass it in an int and pass it in a double. So maybe I'm wrong, but I'll check D. That's correct. I don't like how it worded that. If located in a method in the same class, I just said using this method in the same class. Calling this method. Consider the following class definition. Okay, so we're looking at boiling, freezing, current temp. We have a method called liquid, which is really just setting up our instance variables here. Okay. It's not static, so that means it actually belongs to the object. Public void, which means we have a method that doesn't return anything, doesn't return a value, but it does set the current temp to whatever it is. You subtract 10 from it. And then we have a method called getTemp, which is a double, and it's going to return. This one has a return type. That's why we listed double here, but it returns a current temperature. Okay, assume the following code segment appears in a class other than liquid. Okay, so liquid water equals new liquid. So let's just say it's in, we're writing in the main method here, right? We're creating a object called water, and we're saying water dot lower temp, and water dot lower temp will take the current temperature, which exists already as 50, and we're lowering it, subtracting 10 from it, and that will lower it to 40. Okay, then we're printing out get temp. Okay, and get temp returns the current temperature. Okay, and remember it's as a double, and it would be 40 as a double. All right, so we just trace through that, right? Making sure that we're using the right return type. If we wouldn't have lowered the temperature and just said get temp, if this line wasn't there, right, and just said system.out.println, and we just said water.getTemp, it would have returned 50.0. Okay. The reason why these don't work regardless is because they're not doubles. 40.0. Attempted 8 out of 8 activities on this page. Completed, well done. These are types of problems that would be on the AP exam. Okay. All right, and that's 2.5 calling methods that return values.